We're looking at the final programs that will help you to have a better understanding of two unknowns. And these are more sophisticated concepts, and I hope that you'll get them. We have this program called domain issues. The domain is the set of all the possible x's that can be in an equation. Domain is the set of all x's, and range is the set of all y's. Now, most of the time when I was young, I thought x could be anything when you had an equation, and then you just plug it in and you find the matching y. But there are some equations here, I have them here, that have self-limitations, like there's only some things that things can be, and so we're trying to get you to see what those limitations are. Let's look at this one. F of x is equal to the square root of 4 minus x. Well, when you take the square root, you can't take this in the real world. You can't find the positive root of a negative number. So what's got to happen is that when you have this thing, this 4 minus x, we can't do this or find a matching y, which this would be. We can't find a matching y for this if the stuff that's under this radical is negative. So 4 minus x has to be greater than or equal to 0. So if I solve this to find out restrictions on x, then we get what is called a domain issue, a limitation on the domain. So we subtract 4 from both sides, we get minus x is greater than or equal to negative 4. Now if I multiply both sides by negative 1, I hope you remember, if I multiply both sides by negative 1, I'm going to get an x on the left, and I'm going to get a 4 on the right. But it's not going to be greater than or equal to. It's going to be less than or equal to, because I had to do a switcheroo. So my thing, x has to be less than or equal to, so my answer is going to be this, and it's going to be 4. So I'm going to take the marker out of the way so I can answer. It has to be less than or equal to 4. I hope you followed that. You can back up and watch that part again if you didn't quite get that. Correct. This is what this graph looks like, and sure enough, you can see that there are no values for this function after x is 4. This is what this looks like. Let's do a new problem. Well, if you have a fraction, are there some restrictions on a fraction? Sure enough. I've got a little blackboard here. Maybe it'll be enough. You can't do division by 0. So looking at this problem, I see that there are two numbers in the universe that would make this fraction have a denominator of 0. One would be, look at this denominator here, it's x plus 4 and x minus 1. It doesn't really matter about the numerator. If x were negative 4, we'd have a problem, so x cannot be negative 4. If it were negative 4, the denominator would be 0, and we'd have division by 0. The other thing that x can't be, think about it. What would it be? Hope you got it. 1. Check, we win. And so you see, actually this vertical line shouldn't be here. This function has asymptotes here at negative 4 and at 1, and it doesn't exist. This is a domain issue. Calculators are not good, and you can see my program's not good because these graphs change so quickly that sometimes trying to connect a point here, they'll put this vertical line in. Your calculator will do the same sometimes, and it really shouldn't be there. That's why it's so important to understand domain issues, because in actuality, x could not be 1. It looks like it's could be, but it's not. That's an error, and because you just can't graph fine enough to have it be right every time. Let's look at another problem. Some of you may not have studied logs, but you will in higher levels, and this is really aimed at the higher levels of algebra from Algebra 2. You can't take the log of a negative number. So, that means, and you can't take the log of 0. You can only take the log of a positive number. So, I'm going to have to say that this thing x minus 2 has to be greater than 0, which means x has to be greater than 2. Check, we win. And there's the log graph. Some of you may not have studied that, but that's what it looks like, and it's really asymptotic to 2 here. It never gets to 2. Again, here you can't have a denominator of 0. X cannot be negative 1, and x cannot be 2. We probably saw that problem before. We saw that one before. X has to be greater than or equal to 0, because you can't take. Check, we win. I think that maybe they can't have it. Let's just look and see if we missed something. These are things where there are restrictions. I don't think there's any restrictions on that cubic. It goes from negative infinity to infinity. So get familiar with domain issues, especially if you're in Algebra 2 or pre-calculus. Probably not much of an emphasis in Algebra 1, because some of these functions are a little more sophisticated. But you want to get used to the idea of domain and range. Thanks. Bye.